Good morning, viewers. This is Kasturi Day. Today, I'm going to again discuss the chemical changes and reaction chapter. In my last chapter, I told you what are chemical changes, and then what are the conditions required for the chemical changes to occur. Now, what are the characteristics of these chemical changes, or what are the characteristics of these chemical reactions? These chemical changes occur when there is a chemical reaction taking place. So what are the characteristics of these chemical reactions? We'll start discussing today. Okay, before I start, I will request you to subscribe my channel so that you can get the notification first. And if you are liking the videos, press the like button, share with your friends, and also so that they can also be benefited from these videos. And if you press the like button, that will that will give me some motivation to produce good videos and good surprises for you. I have started some new surprises. There is some question answer sections. I have started some ICSE pattern discussions. I've started. Okay. So I've started some, so some more are in the queue. So for that, you need to subscribe my channel to see all these surprises. And also, I would request you, I've been doing this request for the last few videos, for last of my few videos, that is, please do meditate, do some meditation before you sit to study or start your daily routine. Okay, because that will increase your concentration, and that will give you some motivation to you will feel some interesting things in your subject which you are studying. Okay, you will get the interest. Okay, and the whole day will be going very smoothly. Okay, so please do this meditation before you start the day. Okay, so let me start with the characteristics of the chemical reaction. First one is evolution of a gas. When a chemical reaction is taking place, as a product, some gas is evolved. Sometimes, not always, but sometimes some chemical reactions, there is evolution of gas as a product. Like, for example, zinc, when it is reacting with dilute sulfuric acid, H2SO4, that is when zinc is reacting with dilute sulfuric acid, zinc sulfate and hydrogen gas is produced. There are tests to identify whether the gas is hydrogen or not. Okay, that I will discuss later on. So that is, you can also see that there's some burning splinter if you take to near this one, the hydrogen gas which is evolving, you will see a pop sound. Okay, so like that, there are many this one tests to identify the gas which is evolving. Another example is calcium carbonate, which is a solid calcium carbonate. When it is dissolved in aqueous hydrochloric acid, you will see aqueous calcium chloride, that is in solution. Calcium chloride is formed in the solution form, is found with the water as a liquid, and also carbon dioxide as a gas is coming out. And in this reaction, we can see some effervescence, brisk effervescence when we are diluting calcium chloride, that is when we are dissolving calcium carbonate in hydrochloric acid, we see a brisk effervescence, that is lots of bubble type substance is coming out in the liquid. Okay, that is effervescence. Why this effervescence? Due to the formation of carbon dioxide gas in the reaction. Okay, so you will get as a product, that is carbon dioxide gas, and this carbon dioxide gas can be tested that it is a carbon dioxide gas or not. If you pass this gas through lime water, it will turn lime water milky. Now, next characteristic is of this chemical reaction is the change in color. Okay, some chemical reactions, when they are proceeding, they will change the color. That is the color. What is the color of the reactant will change into some other color as the product is formed. For example, when you cut an apple and keep it in, into pieces and keep it for some time, it will turn brown. Or if iron is reacted with aqueous copper sulfate crystals. Okay, CuSO4. If CuSO4, this is a blue color solution. CuSO4, aqueous copper sulfate is a blue color solution. If we react this blue color solution of copper sulfate with iron, we will see a green solution is forming. The green solution is ferrous sulfate, that is iron sulfate. Ferrous sulfate of ferrous sulfate is forming, which is a green solution is formed. And copper, this blue solution will turn into green, and the iron will turn into copper brown red deposits, and that will be of copper. Okay, the black colored iron will change into brown red deposit, that will be of copper. So the color from the reactant is changing to when it is going to the product, the color is totally changing. Blue solution becoming green, black solid of iron, that will become copper, that is brown red deposit it will form. Okay. Next is the formation of precipitate. In some reaction, some insoluble substance is formed as a product, and that is known as precipitate. Like when silver nitrate, aqueous silver nitrate solution, okay, when silver nitrate solution is reacting with sodium chloride solution, aqueous, AQ means aqueous means solution form, in the solution form. So silver nitrate solution, when it is reacting with sodium chloride solution, then what is formed? It is a silver chloride, white precipitate of silver chloride is formed. Okay, you will see that when these two are colorless, silver nitrate solution and sodium chloride solution, both are colorless. Okay, and when we are taking these two solutions in a test tube, we will see after the reaction taking place, there will be a white precipitate, insoluble substance will be formed at the base of the test tube. It will remain as a white precipitate, and that is the silver chloride. And the solution which will be floating above this precipitate will be sodium nitrate solution. Okay. Next example is of this precipitate is ferrous sulfate. When ferrous sulfate solution is reacting with sodium chloride, sodium hydroxide solution. Sorry, it is sodium hydroxide, not sodium chloride. Please rectify. Okay. There is some mistake in this. Please rectify this equation. So it will be ferrous sulfate and sodium hydroxide. It will form sodium hydroxide and sodium sulfate and ferrous hydroxide, which will be a green dirty green precipitate will be formed. Okay, so when ferrous sulfate is reacting with sodium hydroxide, when ferrous sulfate is reacting with sodium hydroxide, then ferrous hydroxide and sodium sulfate is formed, which will give a dirty green precipitate of ferrous hydroxide. Okay, so these two, when ferrous sulfate and this one sodium chloride, sodium hydroxide, when it is reacting, it will form a dirty green precipitate. When these two solutions are taken in the test tube, we will see a dirty green precipitate settling at the bottom of the test tube, and that is the precipitate, and that is ferrous hydroxide, and the solution above it is the sodium sulfate solution. Okay. Next is okay, so next is the change in the state. So first is evolution of gas, then change in the color, then formation of precipitate, then change in the state. What happens if the two substances which are taken as reactants are solid? We will see the product may become a liquid form or a gas form. So the state is being changed where the chemical reaction is taking place. So some chemical reactions can be identified if they change in the state when forming one or more new substances. Okay, for example, see, ammonia is a gas. Hydrogen chloride is also a gas. When they two react, they form a solid which is known as ammonium chloride. Okay, a solid ammonium chloride is formed. This is a reversible reaction, so the arrow is both ways. Okay, so the two gases, ammonia and also hydrogen chloride, both the two gases are reacting to form a solid substance known as ammonium chloride, which is altogether having the different properties than the other, the parent gases. Okay. Then another one is, example is carbon, which is a solid, and sulfur, which is also a solid. When they two react, they form a carbon sulfide, which is known as which is a liquid. Okay. So the state changes in some where there is, which is showing that is there is a chemical reaction taking place. Next, another characteristic is change in temperature. Some chemical reactions, when they proceed with the they evolve some heat. Okay, or in some chemical reactions, they absorb some heat. When they are evolving some heat, when they're giving out heat, that those type of reactions, those type of chemical reactions are known as exothermic reactions. And when some chemical reactions absorb heat during their process, okay, they are endothermic reaction. Okay, endo means inside, exo means out. So out, that is giving out heat, is exothermic. Absorbing heat, taking in heat, that is endothermic reactions. Clear? Now, exothermic reactions, like for example, see C6H12O6, when this glucose is being burned in oxygen, that is during respiration process, which is taking place throughout our life. Okay, not only us, all of the living things which are present on this universe, whichever living thing is present, all of them respire. So during this respiration process, the glucose is burned in oxygen to form carbon dioxide, water, and energy is released. So this type of reaction is an exothermic reaction, as energy is being released, energy or heat, you can say. So this is a example of exothermic reaction. Now, endothermic reaction, where heat is absorbed, heat is required to for the chemical reaction to proceed to give the product. So in this, for example, see nitrogen when reacting with oxygen. At this time, when nitrogen combines with oxygen, the large amount of heat is required, which is about 3000 degrees centigrade temperature is required. That is, heat is absorbed by this two gases, nitrogen and oxygen, to combine to form nitrogen oxide. Okay, and that this is known as, this is a gas, okay, that is formed. This is also a gas that is formed. This is known as nitrogen oxide. Okay. Now, another characteristics of this chemical reaction is some chemical reactions, as I told you, that some chemical reactions are they evolve heat, like that some chemical reactions evolve heat or absorb heat, like that some chemical reactions also produce sound or absorb sound. They produce light or absorb light. Like that, it also required for the this chemical reaction to proceed. For example, explosion of fireworks. When there is explosion of fireworks, when we burst a cracker, that time what do we see? That heat is produced, light is produced, sound is produced, and unpleasant gases also come out during this chemical reactions. This firework bursting of firecrackers. Okay, so during the bursting of the firecrackers, we see all the four things, that is heat, light, sound, and unpleasant gases are found. Okay, then change in smell. Some chemical reactions occur when they to proceed, they change the smell of the original reactant, the original substance. Okay, like when food is spoiled, we get a pungent smell. No, that is the original smell of the food has been changed into that pungent odor. Then when the formation of curd from the milk, when the milk turns into curd, that time also the smell changes. Souring of the curd, when the curd becomes sour, that time also the taste, the smell, that changes. Even when the vegetables are raw, they have a different smell. When we cook the food, that time the smell changes. Then when the grapes are fermented, that time also the temperature, the smell changes. So the chemical reactions, in these chemical reactions, the smell changes when they proceed into different substances, or new substances rather are formed. Okay. Now, there are types of chemical reactions. 5 types of chemical reactions are there. Okay, excuse me. One is synthesis, direct combination, simple displacement, decomposition, double decomposition. Okay, synthesis and direct combination more or less the same. I'll tell you the difference. What is the main difference between the two? Why they have been separated out? Simple displacement is there, then decomposition and double decomposition is there. So first we discuss the synthesis reaction. Now, synthesis reaction, here it means that the metal, two substances combining together to form a reaction. Okay. So what we see, when metals were combined with oxygen, what happens? Metal combining with oxygen, we get metal oxide. Okay. For example, silver and gold, they do not react with metals. Okay. From this one, potassium to copper, they do not react with oxygen, silver and gold. Okay. Silver and gold, they do not react with oxygen, whereas the metals with metals from this one, potassium to copper, they will react with oxygen to form the respective oxides. Silver and gold, they do not directly react with oxygen to form their oxides, but from potassium to copper, in the metal activity series, I will discuss the metal activity series also with you, with oxygen they form their respective oxides. But in the reactivity series, what we see that the reactivity of the metals, that is from potassium to copper, that the reactivity decreases, it slows down. Okay, like metal oxides are generally basic oxides, and there few of them are amphoteric oxides. Okay, amphoteric means both basic, or that is they behave like a base, or they may behave like an acid also. Both the behaviors are there in the amphoteric oxides, and if they are basic, they will behave as a base. Okay. So this metal oxides, for example, potassium reacting with oxygen to form potassium oxide. Then the reaction with non-metals with oxygen, of non-metals with oxygen, oxygen reacting with non-metals. In this case, the non-metals generally, they are acidic oxides, and few of them are neutral oxides. That is, they do not behave like a base, or neither they do behave like an acid. So these are neutral oxides. So some are neutral, maximum are acidic oxides. That is non-metal combining with oxygen to form non-metal oxide. Okay. For example, carbon is a non-metal, oxygen is also a non-metal. These two combining to form carbon dioxide, or sulfur and oxygen combining to form sulfur dioxide. Now, sulfur burns in oxygen with a pale blue flame. When sulfur is burnt, yellow sulfur, when it burns in oxygen, it produces a pale blue flame. Okay. Now, metals reacting with chlorine. Metals reacting with chlorine. When metals react with chlorine, for example, sodium reacting with chlorine forms sodium chloride. Non-metals reacting with chlorine, like phosphorus reacting with chlorine, forming phosphorus pentachloride. PCl5 pentachloride. Then metals reacting with sulfur, like zinc combining with sulfur to form zinc sulfide. Then non-metals with sulfur, sulfur combining with chlorine. At this time, when sulfur is combining with chlorine, sulfur has to be boiled with chlorine. Okay, that means sulfur, when it is mixed with chlorine, the mixture has to be boiled. Then only it changes to sulfur chloride. Sulfur monochloride. Okay, then it forms sulfur monochloride, S2Cl2. Mind the formulas. Okay. Then Reaction of metals with nitrogen, magnesium, when burned in nitrogen, it will form magnesium nitride. Okay, like magnesium, calcium, and aluminum also combines directly with nitrogen on heating. When on heating, calcium and aluminum also directly combines with nitrogen. Okay, but mind it should be heated. Okay. Then reaction of non-metals with the nitrogen, non-metals like nitrogen and combining with hydrogen. But in this case, catalyst is used, and a high temperature is also needed to combine nitrogen with hydrogen, forming ammonia. And that this process is known as Haber's process. So what is the catalyst here used? It is iron and molybdenum as a it is increases the reaction of the catalyst. It increases the power of the catalyst. Okay, promoter. Okay, so iron is the catalyst and molybdenum is the MO is molybdenum, Fe is iron. So iron is the catalyst and MO is the promoter. It promotes the reaction of the iron. Okay, or the catalytic action. It increases the catalytic action of the iron. And the temperature here it is used is 450 to 500 degree centigrade. So this process is Haber's process. Another another example is nitrogen combined with oxygen in presence of thunder and lightning. In the atmosphere, nitrogen combines with oxygen during thunder and lightning to form nitric oxide, NO. Okay, nitric oxide, nitrogen oxide or nitric oxide. Okay. Next we come to the direct combination reaction. So I told you that there is a little bit difference between synthesis and direct combination reaction. So what do you mean by, first we will understand what is direct combination reaction. In direct combination reaction, here two or more elements or compounds chemically combine to form a single product. Okay, so what happens? Two or more elements or compounds chemically combining to form a single product. Okay, here in synthesis also two or more elements, they combine to form a single product. But the basic difference is that they are termed because the combination reaction in which the combination of two or more compounds occur, okay, to get the desired product, we can call the same process as synthesis, or the product, that is A plus Z, we get AZ. Okay, like in synthesis also, the combination of the two or more reactants takes place, and so we call it combination. But when we need to give a preparation, when we're preparing something, then we call it a synthesis reaction. And when there is direct combination, combining substances is taking place, then we call it combination reaction. That is the basic difference. Otherwise, both of them are same. And in synthesis reaction, we generally see what, that two or more elements are combining together. But in direct combination reaction, there can be elements or compounds, all of them are combining together. Okay, so let us proceed with the different types of direct combination reactions. First is reaction of lower oxides with oxides to form higher oxides. Okay, so we will see, oxygen rather, lower oxides with oxygen to form higher oxides. So what do we see? Lower oxide means, see, carbon monoxide is a lower oxide, which is combining with oxygen. That is, when carbon monoxide is burning in oxygen with a pale blue flame, then carbon dioxide is formed. Even sulfur dioxide, when it is burning in oxygen, in the presence of vanadium oxide, B2O5, and 450 degrees centigrade, we see that sulfur dioxide changing to sulfur trioxide, SO3. So higher oxide it is moving to. Okay, it has been oxidized. More oxygen is added to the lower oxide. Next, another example is, another type of direct combination reaction is reaction of soluble basic oxide with water. The soluble basic oxides react with water to form alkalis, which turn red litmus blue. Okay, so basic oxides, we see that these basic oxides, when they react with water, they form alkalis and they turn red litmus blue. Okay, basic property, it is their basic oxides. Okay, the alkali's property is turning red litmus blue, and acidic property is it turns blue litmus red. Okay, so basic oxides, they react with water, forming alkalis, which turn red litmus blue. For example, K2O, when reacts with water, it's a basic oxide. K2O is a basic oxide. Metal oxides are generally basic oxides. I told you that metal oxides are generally basic oxides, and some of them are amphoteric, but generally metal oxides are basic oxides, whereas acidic oxides are non-metallic oxides. Okay, so basic oxides, like as it is a metal, K is metal, potassium is metal. So K2O, when reacts with water, it forms KOH, which is a base. Okay, it is an alkali. Sorry, KOH is an alkali, which turns red litmus blue. Okay, K2O is a basic oxide reacting with water to form an alkali. Then calcium oxide is also a basic oxide which reacts with water to form calcium hydroxide. That is also an alkali. Okay. Now, reaction of acidic oxide with water. Now, acidic oxides, that these are acid anhydrides, you can call them. Acidic oxides can also be called acid anhydrides because they do not have water. Okay. Now, acidic oxides, they react with water to form acids. Like basic oxides, they react with water to form alkalis. Acidic oxides, they react with water to form acids. And these acids, they turn blue litmus red. Okay. So carbon dioxide, when react with water to form carbonic acid. Sulfur dioxide reacting with water to form sulfurous acid. Sulfur trioxide, when react with water, forms sulfuric acid. Okay. P2O5, that is phosphorus pentoxide, that reacts with water to form phosphoric acid. Okay, and these will turn blue litmus red. Okay, so I'll stop here today. I'll go on, move on to the next type of reaction, that is simple displacement reaction. Okay, so simple displacement reaction I will start in my next video. So till then, please go through these videos through this text portion. If you have any doubt, please write in the comment box. Do share with your friends so that they can also be benefited from these videos. Press the like button if you are liking the videos, and don't forget to subscribe my channel to get the notification of what I am discussing, which video I am uploading. Okay, and don't forget to meditate before sitting to studies, before starting your day. That will increase your meditation, concentration power. That will increase your interest in the studies. That will increase in whatever you do in the whole day. Okay, you will love doing whatever you are doing. Okay. So, and you will increase, that will increase your positivity, okay, in your mind, okay, and everything what you do, that you will be becoming successful as you move on with the meditation. Okay, such power, such type of power is there in the meditations. Okay, so thank you for watching and have a good day.